Have you ever wondered how much sugar is in your favorite drink? Or how much medicine is in a pill? Quantitative analysis in chemistry helps us answer these questions. It's kind of like detective work, but for chemicals. Quantitative analysis is all about measuring the amounts of different substances. We can figure out how much of something is in a mixture, or how pure a substance is. This is super important in many fields, from making sure our food is safe to developing new medicines. Without quantitative analysis, we wouldn't know how to mix the right amounts of ingredients for cakes, or how much fertilizer to use for our plants. It's a crucial part of chemistry that really affects our everyday lives. There are a few different ways we can do quantitative analysis. Let's look at 3 main types. First, gravimetric analysis. This method uses weight to figure out how much of a substance is present. Imagine you want to know how much salt is in salt water. You could evaporate the water and weigh the salt left behind. That's gravimetric analysis. Next, there's volumetric analysis, also called titration. Here, we use a special liquid called a titrant to react with the substance we want to measure. By carefully adding the titrant until the reaction is complete, we can calculate the amount of the unknown substance. Think of it like using a measuring cup to find out how much flour is in a jar, but with chemicals. Finally, we have instrumental methods. These methods are like having high-tech helpers in the lab. We use instruments like spectrometers and chromatographs to measure light or other signals that tell us about the amounts of substances. It's kind of like using a fancy camera to see things we can't see with our eyes. No matter which method we choose, there are a few basic steps involved in quantitative analysis. First, sampling. We need to take a small sample of the substance we want to analyze. It's a bit like taking a tiny bite of a cake to see what it tastes like. Next is dissolution. We often need to dissolve the sample in a liquid to make it easier to work with. Imagine dissolving sugar in water before adding it to your lemonade. Then comes measurement. This is where we use our tools and techniques to carefully measure the amount of the substance we're interested in. It could be weighing a precipitate, measuring the volume of titrant used, or analyzing a signal from an instrument. After that, we have calculation. Once we have our measurements, we use math formulas to calculate the amount of the substance in the original sample. And finally, reporting. We present our findings in a clear and organized way, just like writing a science report. 2 important concepts in quantitative analysis are accuracy and precision. Accuracy is how close our measurement is to the true value. Imagine throwing darts at a dartboard. Hitting the bullseye means high accuracy. Precision is how close our measurements are to each other. If you throw 3 darts and they all land close together, that's good precision, even if they're not in the bullseye. Organic compounds are like the building blocks of life, and they contain elements like carbon, hydrogen, nitrogen, halogens, sulfur, and phosphorus. To figure out how much of each element is in an organic compound, we use special methods. For example, to measure carbon and hydrogen, we burn a small amount of the compound in a stream of oxygen. This produces carbon dioxide and water. By collecting and weighing the carbon dioxide and water, we can calculate the percentage of carbon and hydrogen in the original compound. Let's say we burn 0.2 grams of an organic compound and get 0.3 grams of carbon dioxide and 0.1 grams of water. For carbon, the atomic weight of carbon is 12, and that of oxygen is 16. So the molecular weight of carbon dioxide is 12 times 1 plus 16 times 2, which is 44. This means 12 grams of carbon is present in 44 grams of carbon dioxide. Now we can set up a proportion 12 grams of carbon over 44 grams of carbon dioxide equals x grams of carbon over 0.3 grams of carbon dioxide. Solving for x, we get 0.082 grams of carbon. Finally, to get the percentage of carbon, 0.082 grams of carbon divided by 0.2 grams of the sample times 100% gives us 41% carbon. For hydrogen, the atomic weight of hydrogen is 1. The molecular weight of water is 1 times 2 plus 16 times 1, which is 18. This means 2 grams of hydrogen is present in 18 grams of water. We can set up another proportion. 2 grams of hydrogen over 18 grams of water equals y grams of hydrogen over 0.1 grams of water. Solving for y, we get 0.011 grams of hydrogen. Finally, to get the percentage of hydrogen, 0.011 grams of hydrogen divided by 0.2 grams of the sample times 100% gives us 5.5% hydrogen. Now, here's a practice problem. Imagine you have 0.5 grams of a new organic compound. After burning it, you collect 0.7 grams of carbon dioxide. Can you calculate the percentage of carbon in this compound? Using the same steps as above, we find that 0.7 grams of carbon dioxide contains 0.19 grams of carbon. Therefore, the percentage of carbon in the new compound is 0.19 grams of carbon divided by 0.5 grams of the sample times 100%, which is 38%.